Aliasing. Aliasing is a result of undersampling and is a well-known phenomenon. In ref, aliasing was looked upon from the point of view of symmetry. It is an example of wrong symmetry and as such should be given more attention. It is the outcome of an incomplete basis. It was found in ref that for evenly sampled data with a sampling rate fs, the spectral amplitude SF evaluated with FFT has the following symmetry properties. Where f is the frequency and n is an arbitrary integer. In order to avoid the aliasing symmetry of 17, the frequency should be bounded by the Nyquist frequency, denoted here by Fb, according to the ECG signal was sampled with sampling rate 250 Hz, and an electronic filter was applied, which have eliminated practically all frequencies above 32 Hz, thus aliasing cannot occur at frequencies below 125 Hz or even below 32 Hz. The RR intervals were calculated directly from the ECG signal. The sampling rate for RR intervals can be defined only for evenly sampled data and for the methods that interpolate the unevenly sampled data, or one can consider the average sampling rate from 1, in both cases. Where Fn is the Nyquist frequency for the RR intervals. As the ECG signal contains frequencies much greater than Fn and the RR intervals are derived from the ECG signal, one cannot be sure that the spectral analysis of the RR intervals is free from aliasing. As a matter of fact, there are indications of aliasing in some rare cases. One way to identify aliasing is to change the sampling rate and follow the changes in the spectrum. Unfortunately, for the RR intervals, one cannot speak about a definite sampling rate but rather can consider a distribution of sampling rates. The changes in sampling rate required to observe aliasing are of the same order as the fluctuations in the sampling rate. Therefore in practice it is almost impossible to observe consistent changes in the spectrum slightly changing the heart rate. Another possibility of detecting aliasing is by comparing the heart rate spectrum with the ECG signal spectrum. Marked differences below the Nyquist frequency for the power distribution of the RR intervals compared to the ECG signal power distribution in the same range may indicate aliasing. But we do not have yet a sound basis to treat this problem. We have devised an experiment which definitely demonstrates the aliasing in the RR interval spectrum. To the best of our knowledge, this is the first experiment in which one can exactly know the correct frequency above the Nyquist frequency and can follow the development of the aliasing, which appears to be diffused to great extent because the symmetry of 17 is represented not by one sampling rate but by a distribution of sampling rates, as the RR interval is unevenly sampled. Below we describe 3 experiments. One of them was devised to demonstrate aliasing and the other 2 for learning about the relations between the RR interval spectrum and the spectrum of the ECG signal.